So after I did this with the students after they had 20 minutes, then I gave them the vote of whether or not to do C and D. And with both periods 1, 2, and 3, they all wanted me to do examples C and D for even and odd. So I'm going to do that with you. So let's talk about, first I'm going to check for even. And a reminder that that just means f of x equals f of negative x. So I'm going to find f of negative x and compare that to my original function. So it's cubed and I plug in negative x. Let's do this. Write this out because I think we need practice. So if you look at the first two, a negative times a negative is a positive. So I'm going to change these to pluses to show this is positive. So I still have this remaining negative, which makes the entire problem negative. So this changes sign. So this one is negative 5x cubed, and then the minus 1 is there. Is this just like my original function? Is this one? No, because of the negative sign. So it's not even. This fails. Now for odd, a reminder is f of negative x equals negative f of x. So for 5 of negative x cubed minus 1, does that equal negative f x cubed minus 1? So I'm not going to go into great detail about this because I wrote it out when I checked my even. But that is going to flip this sign. So 5x cubed becomes negative 5x cubed because of that 3. So odd exponents flip the whole problem. And I'm going to distribute this to negative, and that makes this one positive. So negative 5x cubed plus 1, is this equal to this? No, because of the minus 1 and the plus 1. So I'm going to put not equal, and I'm going to say neither. And if I was writing this out on a quiz or a test, and I would say this function is neither even nor odd because it is not, because f of x is not equal to f of negative x, nor because f of negative x does not equal negative f of x. So I'm going to use my definitions in my sentence solution. For D, so let's check even. So I'm just gonna write this out again. So I'm gonna compare with the original function. So this is a negative x, this is a negative x. I'm going to write this out, and I'm going to have a lot of parentheses. So these are 4 negative x's. 2, 3 x's, and 4 x's. Minus, and then I've got 2 negative x's in this one. Negative x, plus 2. All right, let's talk this out. These two turn to positive. And these two, a negative times a negative is a positive. So does this negative 3 right here stay a negative 3? Yes, because negative 3 times x to the 4th, because these are all positives now, remains negative. So this simplifies to negative 3x to the 4th. Nothing changed there. Let's look at this one. These two are both negative, so they make a positive. So this negative doesn't change. That first negative right there, so it's minus x squared plus 2. Is this right here the same as this right here? Negative, negative, positive, negative, negative, positive, yes. So this is even because, that's our abbreviation for because, f of x equals f of negative x, and we don't check for odd because it's not even or odd. So for this, which is on the bottom of your notes on page 2, let's just read along this one. So if a function is increasing, then as the values of x get bigger, the values of the function also get bigger. It says using the same idea, what happens if the function is decreasing? So I'm going to say as, and I might have to write somewhere else, as x values get bigger, and x values getting bigger is just going from left to right. Y values, and I should really write values of the function, but I'm not doing that because of space, sorry, that's just one t, smaller. Okay, let's do the blue one. What happens when the function is constant? So as, I'll write this out, x values still get bigger, the values of the function and this is going to be stay the same, and I'll show you what that means in a moment. So I'm going to color code pictures. So the first one's going to be black. So increasing is going to be black. So what does that mean? And you might want to draw the pictures in the margins, or you might want to make a code like me. So increasing, as x values get bigger, they also get bigger. So remember, x values getting bigger just means we're going from left to right. But if we connect these dots, as x values increase, the y values go up, 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 up. Okay? Decreasing will be pink. So let's take a look at that. Again, my x's increase, so they just go from left to right, but my y values get smaller. So they're going to go down. And constant's going to be in blue. Hopefully we're thinking about in our mind what that means. So as x values get bigger, because we're going this way, so yes, they're getting bigger. You know, this is -2 or whatever, so they're getting bigger. But the y value stays the same. If this was 5, it's 5 the whole time. So that's what it means to be constant. So again, you could take a break if you wanted to, but you can also go to the next video. In periods 1, 2, and 3, we just did some more work.